In this video, we're going to look at determining if a graph has a point of discontinuity at a specific x value. So we're going to do this using the calculator. So we'll practice testing for points of discontinuity using the calculator. So looking at this first example here, we're going to take a look at the graph. So here's my graph, and this specific question is asking if there is a point of discontinuity at x equals 0. So in order to do that on your calculator, we're going to go second trace value and then put in the specific value that they're asking about. In this case, that is 0, x equals 0. So x equals 0, y equals nothing. So this is indicating to us that y is undefined here, which would indicate a point of discontinuity. From this graph, we could tell that there's a point of discontinuity. There's an asymptote here on the y-axis. So there is a point of discontinuity, x equals 0, and it would be non-removable because that is an infinite point of discontinuity. Now, if we take a look at this second graph here, we have absolute value of x over x. If we take a look at that graph, we can see that this is two horizontal lines, and there's a bit of a jump discontinuity in here. So again, from the graph, we can tell that. But just to double check, we're going to go second trace value at x equals 0. Again, y equals nothing, so y is undefined. So we do have a point of discontinuity. This is a jump discontinuity, so we would, again, label that as non-removable. Looking at our third example here, we're going to graph this equation, 3x minus 4. From the graph here, we can see that this appears that this is a continuous function. Just to double check, we're going to go second trace value again at x equals 0. And at x equals 0, y equals negative 4. So when x equals 0, y is defined, so it is continuous at the point x equals 0. So obviously then we don't have to worry about classifying it. Now looking at our final example over here where we have y equals x times x minus 2 over x, we're going to go ahead and take a look at that graph. Again, this graph appears to be a continuous graph, but we always want to double check. So we're going to go second trace value at x equals 0. Again, here we get the y equals nothing, so y is not defined at x equals 0, so there is a point of discontinuity there, although it does not appear on the graph. So it's just a sort of feature of your calculator that it can't be that precise. Technically, for this graph, there would be a hole on this graph, so there would be a hole here, but your calculator just doesn't have the precision to give you that. So that's why you want to always double check on your calculator if you're looking for a specific value. And anytime you have y equals nothing, that implies that your function is not defined there, and then you would have a point of discontinuity.